Hey guys, welcome to another episode of the Real Hacker Hours podcast, where I basically just put a camera on whatever projects me and my friends are working on at the time. This time it's going to be kind of a episode very similar to the previous one, where I'm just going to be previous episode I reversed out this process where Sqlite3 will insert a new record. Now I'm just going to kind of do the inverse and do reverse out the selection process. So here is the table that's open. I'm going to first try to get the opcode so I can see exactly what operations are happening in order to get the selection working. For that, this is actually, hang on a second, let me set this breakpoint. Okay, effectively what this breakpoint corresponds to is, if we go here, actually let's here we go. Okay. So this switch statement right here that actually executes the opcodes, which is where the actual work for servicing a SQL query happens. This memory address corresponds directly to that point, so we can effectively just see what opcodes are being executed. And now that we have that breakpoint, I'm just going to run this. Also, this is the contents of the table, effectively just each. Oh, there are two columns. The first is integer, second is a string, and then 3 rows. And let's run this query. And now I'm just going to get these 0x3. 0x02. Yeah. Effectively, like the opcode number will be in the RAX register. And I'm just going to pause the recording for now so I can just go ahead and get all the values. Also, one other thing, we can see that OX3E corresponds to 62, which if you look at the code of ops, this is generated in one of the source code files. You see is op init. So I'm just going to go ahead and get all of those opcodes, and then I'll restart the recording. Okay, cool. So I got the opcodes, which are right here. Effectively, you have the beginning 3 opcodes that we always see: init, transaction, go to, op open read, which that should just open up a cursor to the table for read. Oh, well, in read mode with read permissions. Op rewind, what this does, I believe, is it will configure the cursor to point to the first row and configure it that it will traverse it from first to last record. And then we have op column opcodes, which I believe will read a single column from a row. Op result row, which will compile the various columns into a row. And then op next, which will move on to the next row. And then we see that this happens, this happens 3 times. That is because there are 3 records that happen. We see after the last one, when it runs op next, that it will effectively realize that, hey, I'm out of rows, and just run op halt. So let's take a look at some of these. Op open read. I believe this is going to be fairly similar to, yeah. This is literally the same opcode as op open write, which, as you saw in the last episode, basically relies on SQLite btree cursor to just open up a cursor to it. Cool. Moving on to op rewind. Yeah. rewinds it to the first record and so okay. It looks like it will do so either through the use of this function or that function. Excuse me for a second, I had a burp. I'm kind of curious. I think it would be the Sqlite3 B tree first, but let's see which function actually gets executed. Select all from X, and this is the 5th opcode that is ran, so 2, 3, and 25. Yep, this is it. Let's see, break at Sqlite3 B tree first. Hopefully this is not inlined. Okay. Okay, they're both inlined. I'm just gonna step through to that to see which of the two. Okay, yeah, it is Sqlite3 B tree first. And I'm just gonna take a quick look under the hood to see how this function works. Okay, it uses move to root, looks like. Which, reading comments for a second, probably has some good info. Okay, cool. Looks like it just actually. Yeah. I'm not gonna be able to tell exactly how it's doing it just from one glance. It looks like it's just like leveraging some of like the metadata on the page to determine that. Cool. So next up, let's look at op column. This is going to be, if I remember correctly, this is going to be the primary opcode where the actual function of retrieving data happens. Interpret the. Yeah. And unlike op insert, the majority of the functionality actually happens in, as we can see here, actually happens in this opcode itself. It isn't like delegated out to like a sub function, which is then called. Let's copy this into a separate tab so we can look at it better. Okay, I'm going to pause it for a second. Okay, and I am back. So this right here is the code for actually executing an op column. I'm reading the comments. Okay, cool. So P1 register holds the cursor. The extracted value is stored in P3, which for me we've seen with other opcodes is typically the output. And I believe P2 specifies what. Yeah, P2 specifies the column that they want. So, okay, let's start looking for exactly what they want. Okay, just gonna take a quick look through here. Okay, we're seeing some checks here. I wonder what are these values we're seeing? It's probably going to take a minute or two before I can say anything that makes sense here. Okay, so this is where it actually gets the value. Okay, cool. This right here is where it calculates the offset to the value in the record. Okay, cool. So what is this stuff up here? So this is for pseudo cursor. Looks like this is for a null row, which we probably don't have to do, which we don't have to deal with here. Else. Okay. Here PC says row greater. What is a offset set equal to? A offset to PC. Oh, okay, so that's okay, so it's a collection of offsets to various things. Size of the row. Okay, so this is checking that if okay, so this right here is checking. So a offset is the like I said, contains offsets to the various values of various offsets to the various columns of it. However, I don't believe it's actually those values are actually set until down here. But so what we can see here is that it's initially set equal to the offset to the row from what it looks like, and we know that the first val, which should be the header, and we know that from when we reverse the insertion, we know that the first value of the header is the size of the header. So effectively what this here is checking is that the size of the row is not less than the size of the header, because in that case you'll extend past the size of the row. And if this check actually fails, and if the size of the header is greater than the size of the actual record itself, does an additional check right there, which just checks, oh hey, is the header size greater than this, or the size of the header is greater than the expected payload size, then it marks it as corrupt. Okay, cool. This just appears to be just like the normal case. Where it is. Okay, cool. So this loop right here is where, actually, let's go to, so most of the time this condition will go and then it'll just jump to op column read header, which is right here. Starts off with this offset equal to that. I'm going to take a second to understand this, what's going on. Z header is equal to Z data plus Z header offset. Okay, so that's what that is. Nice, the iteration count, okay. And what is T? Okay, cool. So what I can tell from here, this Z header is initialized to the start of where the actual header values are. They're specifying like, hey, this is a string of X size. This is like an 8-byte int. This is like a 2-byte int, stuff like that. Does so by adding the offset to the header to Z data. This specifies that the end of the header, which it does by adding the size of the header to the data. This loop will run until either, and also I stores like which column we are like parsing or parsing like the second, third, whatever. This loop will run until either I reaches the desired column we wish to extract, or the header passes the end of the header. And we see every time that it runs, Z header, if it's an integer value, just getting increased by 1 since the type value for integer should just be a single byte. If it's a string, then it gets whatever the size of the string type is, which is calculated via this function call right here. Offset 64, this will store the offset for whatever it is. Note that it increments, and that the A offset value, it is set equal to whatever is calculated from that. This right here is for string values. This right here is for integer values from what I can tell. So this effectively calculates all of the, assuming that there's no like weird corruption going on that would prevent it from stopping it, and calculates the offsets from the first column to whatever column we're trying to extract. This right here is some error checking. If the bytes of the header extend past the header size, like it basically if these three conditions are met. Header extends past the declared header size, entire header was used but not all the data was used. And if the end of the data extends beyond the end of the record, so if effectively like runs off the end of the record, then it's going to mark that. And then this check right here is for dealing with nulls. So let me just take a second to understand what's going on here. Okay, so effectively for what it looks like is that if it is missing, if the record is missing columns, then it's assumed to be null. And then finally we get to this part, which is where it actually will extract the value. Now there are several different ways you can do it depending on what the type of data it is. 12, if it's below 12, then it'll just use this, which primarily used for integer values. If, let's see, I think this is for strings. Yeah, this right here is used for strings, and this right here is used for like overflow pages, which is like when you have a table that extends beyond past multiple memory pages. That, if you want more of that, check out like the memory documentation on the Git repo that I have all of the documentation for this on. And then it will ptest. Wonder where is ptest actually set as the output? Okay, yeah, it's set equal to the address of P3, which is the output. Cool, so we now understand how op column will extract a single column value. Next up, let's look at result row. Okay, cool. So this opcode takes a variable amount of arguments which effectively control the rows to the result, which I'm assuming is output. Okay, let's see. No terminate. Looking, it's going to take me a. Okay, so it's Sqlite3 row. Let's see what this .xv2 function is. xv2 equals xtrace. I get the feeling that xtrace is another alias used. Xtrace. No. No. Let's go there. I'm just gonna go to the result row opcode just to see what function is actually called there. And this should. Yeah, this is result row. Okay, yeah, we're in the function now. Let's just pmem4. Okay, so this loop, from looking at it, this is where I actually add each individual column value. What is this function? Okay, so make sure that I can pmem right to the string. Sqlite3 null term. Okay. Let's see. dbtrace. This is line. What line is this? pmem 87. Okay. 7 4. So I'm just gonna set a breakpoint for 87. 87467. And just skipped over it. Def if term. Okay, cool. So this doesn't this function, this .xv2 function doesn't actually get executed under normal conditions. I'm defining normal as like just the query I ran, so don't need to worry about it. Primarily, this loop right here is where it actually forms the like record, from what I can tell. Cool. So we know up column And let's just look at op next. So op advances it so we can look to the next one, but if there are none, it will signal that. The X advance. Oh, so it looks like it uses I spelled that wrong. Advanced. It uses this function. Let's set a breakpoint for this just to confirm. And yeah, so I use the Sqlite3 B tree next to actually move it forward to the next entry, which uses B tree next, as we can see. Let's see what it does. Move to child. Okay, I'm not gonna continue going down the rabbit hole here, but we can see it calls upon several different functions to handle the lower level logic of actually moving it to the next one. Actually, I'm really curious. Tree next. Oh wait, no, I misjudged at first glance. Seeing here, from what I recall, this value right here, peak cursor ix, points to signifies the exact the current entry or the current row it's pointing to. But so I'm not just flat out wrong. Let's look at the struct for this and see what the value of ix is. Ix current index. Okay, yeah, so it's the current index for the row. No, B tree next. So yeah, we can see it increments it, and then it does a check to see, oh hey, is the current index greater than or equal to the number of cells on this page, and if so, call these different functions to handle the logic for that. Cool, so we understand that roughly. So we know what OpenRead does, reline, column, result row next. Yeah, that is pretty much everything on a rough understanding. So just to reiterate, OpenRead opens a cursor to the database file, rewrite configures it to point to the first record of the actually OpenRead opens a cursor to the table, not the database. Two different things. Op rewind makes a point to the first record of that table and configures it to go from the first record to the second to the third and so on and so forth. Op column will extract a single column from a row. Do you see there are two op columns because there are two columns to each row? Op result row will compile that into a single, effectively like a string that will be outputted. Op next moves to the next row, and we see this process repeated until it runs out of rows, which will then just run op halt. So with that out of the way, I'm just gonna type up some documentation to just state all of this. But with that, I'm gonna end it here. Thanks for watching.